Hello, let's take a look at ng.Grace online substation automation design tool. This software allows user to create projects for substation automation according to IEC 61850 standard. This software allows user to import pre-made SCD file or create single line diagram manually. It allows user to choose Russian or European style of schema elements. Right now we are creating a new project and import single line diagram from substation specification description file. Let's take a look at this. So the software, the ng.Grace software, automatically distributes elements of single line diagram on the schema because common SCD files do not have information about coordinates of elements. After that, elements can be manipulated on the list. We have to input additional data about the transformers because SSD file doesn't contain information about their parent power. We can adjust schema using the elements from the library. There is a huge set of elements over there. We can adjust different properties of the elements, select proper names for them, and so on. After that, we can check the validation button, and after validation is completed, we can lock this stage and proceed to the next stage. The next stage is processed automatically, but we have to choose a set of rules that is used to synthesize design decisions. Right now we select EON set of design rules and follow to the next stage. As you can see, the ng.Grace software automatically created a set of logic devices and logical nodes for each relay protection function that was automatically chosen according to a set of rules that was selected. And all these logical devices and logical nodes are attached to protected equipment, as you can see here. We can make some adjustments if you would like to. The ng.Grace software allows us to manipulate synthesized logical nodes and logical device using these trees over there. So we can select some function and it's automatically zoomed to the selected function. We can add new functions to existing devices. Let's make something, I don't know, like that, and add some logical nodes if you would like to, like this, maybe like this, and so on. Then we should check this validation button and see if everything is all right. Okay. Next stage, we will synthesize a set of IEDs and merging units that are needed to process all these relay protection functions that have been automatically synthesized or manually added on this stage. Okay, let's lock this stage and go further. Okay, next we should select PAX architecture and vendors for IEDs and merchant units. Then click synthesize buttons, and now we can see that on this schema we have a set of IDs and merging units attached to protected equipment, and all the protection functions that were synthesized on the previous stage are distributed among these um, IDs and merging units. We also have ability to uh, change the pre-synthesized set of IDs and merging units if we would like to, and let's say rearrange the set of logical devices between IDs and so on. After that, we click the check button to validate the resulting schema and go to the next stage. After locking this stage, the next stage is logical area network synthesis. Um, we have to select what kind of local area network we would like to see for the SCADA level. Let's take a simple one, and vendor for the Ethernet switches and other network equipment. Let's pick Hirschman. Okay, let's go to the next stage. Now the system automatically synthesized a local area network structure, including um, primary and backup process bus, primary and backup substation bus, and a set of devices for SCADA system like KVM switches and servers and workstations and so on. We can click some lines to see where they're going to, and if we choose some equipment from this tree, we can see highlighted all the uh, all the mm, Ethernet cables that are attached to each device in the schema. So this schema was synthesized automatically, but we still have ability to change it. So we can add some like server to some of these cubicles. Let's say we add this one. Okay, so it appears to be somewhere here. Okay, it's here. So now we can attach it to somewhere like this, and so on. Then we, as always, click check button to validate the resulting schema that we have created. After this process is finished, we can lock this stage and proceed to the next stage. Next stage is calculation of the total cost of ownership. So we have to input some data related to capital and operational costs that should be taken into account to calculate total cost of ownership for the substation automation system, and click synthesize. Now we can see the calculated values and some statistical information about relay protection system and SCADA system, including a set of count of IDs, merging units, Ethernet switches, cubicles, and so on, and also the total cost, the total capital cost and operational cost for each year, and the summarized total cost of ownership, and also reliability indexes that are presented on this diagram. The green line is an edge value for each index. So if our system is located somewhere inside these green boundaries, then we are good to go. After that, we choose to lock this stage and proceed to the final stage. On the final stage, we can export documentation, although we can export it on the each stage that we were working on. Let's say we export to vector SVG format, that is stands for scalable vector graphics. So this schema is editable in Microsoft Visio, Inkscape, or any other vector graphics software. It has some ISO frame that we used to see in modern design documents, and so on. We also can export this documentation in SCL format. So let's see how we can open it here. Well, let's take a look at this. Okay, so now we can see that we can export SCL compatible documents for single line diagram, substation specification description, substation configuration description, and so on. For the local area network stage, we can export cable list that contains all the cables that were synthesized and added manually, and equipment specification, including relay protection devices, and also SCADA level devices like KVMs, workstations, servers, routers, and so on. After that, we can also export all these documents in one zip file that contains all the documents for each stage. We also can change some settings for the exported documents like company info, responsible persons, and so on. So that's a complete solution to design substation automation systems according to IEC 61850 standard. Well, that's all. Thank you very much.